Just we are discussing effects of refraction. Now we are referencing three effects. Out of this one, first is partially immersed pencil or stick or any object appears to bend at the surface of water. Why? Refraction of light is the reason behind this one. See, this is the pencil AO. AB part is above the water, BO part is below the water. The part which is below the water, the light gets reflected from this point or from this pencil. First has to travel from water, then traveling from air and reaching the person's eye, and that observer is observing the pencil. But how actually rays are traveling? See, these are the two rays traveling towards that person. For example, we are discussing two rays. Here, medium get changed. Which medium is there? Denser medium to rarer medium. And so, because of this denser medium to rarer medium, refraction will be there, changes medium, and rays will bend away from the normal and reaches the man. But the man getting these rays, not from the object, if you extend these rays backward, means like this one, rays are actually going to meet here. That point is I. Though the point is inside the water at point O, the person is observing that point little higher than the original position. So what is O? O is a exact position of point. And what is I? It is apparent push. It appears become upper or little higher than the original position. What is true with this one point? It is true with all the points. All the points within the water appears little higher, and the pencil will be observed like this. So see here, up to A to B, pencil is straight, but the pencil part which is immersed or the sticks part which is immersed into the water, it appears little bendy. Why it happened? Because of refraction of light. Second is there, an object placed under water appears to be raised. See this example. This container is having water. At the bottom of this container, one object is there. Consider a little coin is there. The rays which are traveling like this one, that is incident ray. But see, these are the normals. Because of this normal, we are getting the correct refraction. Denser medium to rarer medium. Rays will move away from the normal. That means rays are moving away from the normal and reaches the person. But when rays reach to the person will observe that object straight, not the bending. And so if you extend these rays, if we extend these rays like this one backward or downward, we are getting that object is here. So what is this one? This position is exact position of original position, and this is the image of that object we are observing. It is little higher, and because of all these conditions here, because of only refraction. So the objects which are below the water appears little higher than exactly their position. So be aware when you are going to get entered into swimming pool, the objects on the floor which is below the swimming pool appears little raised. That means it is more deeper than it appears. The third point is there, mirrors. See what is mirror? Generally we are observing wherever there is roads or within the desert, we are appearing something flickering images there. So how it is going to happen, that we are going to discuss here. The concept, the third concept we are discussing, that is mirrors. See, this is a plain road or a desert. Within this, one tree is there. We know that this is a solid material, that is the road, and because of this one it gets heated. So temperature above this part, or air temperature above the radar little higher. As temperature higher, medium may be rarer. So temperature plays very important role. Because of higher temperature, the layer number 4, air of layer number 4 is more rarer than little upper. As we go up in the air, temperature goes on decreasing and so density increases. So when we observe these layers, just for example, I am discussing 4 layers. Every above layer is more denser than the lower layer. So density of first layer is little higher than the density of the second. Second is higher than the third, and third is higher than the fourth. Rarer medium is like the fourth medium or downward medium. The rays which are incident rays which are coming out from the tree, here there is a change in medium because second medium little rarer. When from rarer medium to denser medium, the rays should go straight, but it will bend away from the normal. It should go straight, but again for the second layer, it is again bending and layer reaches the third layer. By bending it bend downward, downward, downward. And as it is bending downward, little downward, downward, see here, the last phase we are reaching here incidence angle is little more than the critical angle. Incidence angle is more than the critical angle, and here total internal reflection we are getting, and without bending down, this ray will travel straight to the observer. But the observer is getting the rays or image of the tree he is getting here, but he is observing the rays are coming from the tree, from the floor, and so he is getting the image of the tree which is coming out from the floor, and so here on the floor he is getting a faint image, and this position is called as mirage. So mirage is totally the effect of refraction and total internal reflection. See here, again some points we are discussing. The fourth point is twinkling of star. We have been singing the song from our childhood, Twinkle Twinkle Little Star. They are little, so twinkling. Means what? See here, the star is so far away from the earth. We are the observer standing on the earth. During the night we are observing the star. This one is a star. Star is self-luminous. That means it has its own light. But what about the atmosphere? Atmosphere is not constant everywhere. We have known that, we have studied that atmosphere is more dense around the earth, and as you go at the higher altitude, atmosphere is rarer, rarer and rarer, and beyond some limit there is a space where we do not having any kind of molecules, and so no restriction, so refraction is not there. When we come towards the earth, density of atmosphere goes on increasing. That means when light is traveling from the star, first it has to travel the rarer medium, then denser, rarer, then denser, rarer, then denser. That means while traveling from rarer to denser, that ray has to appear to the observer. So see, first when we are considering the first ray which is coming out, incident ray from the star, and it is space, there is no refraction, no change in the direction of light because air is not there. But when atmosphere starts, definitely there is a change in medium. Though both air medium are there, one is a vacuum medium, one is a air medium, so it is a more denser. So when denser medium is there, refracted ray move towards the normal, and without going its straight, it will move little down. Again what will happen? So again there is a little denser than this one. So again ray will move little again downward, that is towards the normal. Again not it is enough. Again here is the third medium starts going to start, and so ray will move again the normal. towards the normal. And like this one, by little bending, lastly the observer is getting that light. But see, though this light has traveled in the curved path, it is not a straight path, it is a curved path. But the observer, he is getting the light coming straight to him, and so we have to extend this line like this one, and so the observer is observing star little above the original position of a star, and so it is called as apparent position of a star. So during night where we are observing star, actually they are not there, they are little down that one, they are little below the origin, below the apparent position. So it is not a twinkle, it is twinkling of star. It is a one cause of twinkling the star, but actually it is we are observing the star above the original position of the star. Actually twinkling is happening because of refraction. How it is, I am explaining now. See, though the mediums are different, the medium is not stable, because air is a fluid, it will move, and as movement is there, temperature plays a very important role, then concentration is playing also important role. Suppose in this layer concentration of oxygen and nitrogen is more, here is less, so density may differ, and as density is differing, definitely refractive index is always changing. So refractive index of atmosphere is not constant everywhere, it is changing, and because of this change, light will not travel in definite path. Light will travel like this one, somehow it will move towards the left, somehow it will move towards the normal, somewhere it will move towards away from the normal, and like this one we are reaching, the light is reaching to the observer. See what will happen, this one is the observer and light is coming out somehow to the person like this. When he is getting more light, he will consider, or the star will appear more brighter. If these rays will not travel to the observer, they will travel away from the observer. Only one light, for example, only one light he is getting. So as he is getting less light due to refraction, the star appears dim. When again, because of change of refraction, many light is concentrated towards the observer, definitely again the person is getting more light, and so he will appear the star as a brighter. So this is changing every time. So somewhere he is getting that star little brighter, somewhere or at some point time he is getting that dim. So always there is a dim, bright, bright, dim, bright, dim, and again this position is not confirmed because this air is moving always. It is refractive index is changing, and so star appears little here and lower, higher and lower, higher and lower. It is changing its position. Along with the changing in position, sometimes it is brighter, sometimes it is dimmer, sometimes it is brighter, sometimes it is dimmer, and this is going to happen every time. And so combined effect of this one, movement of the position and light is dim and brighter. So combined effect of all this is called as twinkling of star. So twinkling of star is going to happen because of only refraction. So one question is remaining here, why planets will not twinkle? See, as compared to star, planets are very close to the earth. This one is a tiny. So whatever may be the change within the point source, we can get observed. But when we are considering planet, within the planet many points are there from which we are getting the light. Suppose this point is dimmer, then many others are brighter. When this bright point convert into dim point, or it will not reflect light towards you, many points are there which is reflecting lights towards you. So the light we are getting constantly same light from the planet. Though there is a refraction or reflection, we are getting the constant light from the planet. So planets will not twinkle, only a star will twinkle. One more concept we are discussing here, and that concept is early sunrise. See how early sunrise will happen here. Suppose this part is considered Earth. Many layers are there. These are the layers of atmosphere which is not constant, and again each lower layer is more dense than the upper layer. So when it is a horizon, when sun will reach at horizon, then only the observer can observe that sun or not. Now the sun's position is little down or it is below the horizon, but light is traveling like this one. Now see, rarer to denser, it will move towards normal. Again rarer to denser, it will move towards normal. Again rarer to denser, it will move towards normal, and finally the ray will reach to the observer. So how is light is traveling within the atmosphere? In the curved path. But the person who is getting that light curved path, he assumes that I am observing that light straight, and so you will have to extend this ray like this one. Though the sun's position is little down, he is observing that some rays are reaching, and so sun is not very furious early in the morning. Sun is little dim in the morning, so he is observing the sun above the horizon, though the sun is below the horizon. So though the sun is not at the horizon, we are getting that sun. So what is the time here? The time is of 2 minutes. So 2 minutes early sunrise we are getting, though the sun is below the horizon. So what is the reason behind this one? The reason behind this one is refraction of light. What is true with this one? Sunrise. That is true with the sunset. When sun is below the horizon, because of refraction, it will adopt the curved path. But we are able to see that sun on the horizon. How many minutes? 2 minutes. So there is a 2 minutes early sunrise we are getting, and 2 minutes delay sunset we are getting. So 4 minutes we are getting light more from the sun. So it is a gift of refraction. Thank you.